In this video, we need to match a graph with the corresponding equation. So you'll see we're given two graphs and four equations. So I'm going to start with the first equation and see if I can match it with one of these four down here. So the first thing I want to start with is looking at where the max and min values are on this graph. I've got a maximum value at 5 and a minimum value at -3, which means my midline is going to be halfway between those two, or at 1 here. So that's the first thing I want to get. Because when I look down here, I'm going to notice that I have one function that doesn't have a midline at 1. So I know it won't be 3 for graph number 1 here. So now I'm going to look at the amplitude. Let's look at the amplitude. The amplitude would be the distance from the midline to the maximum, which for this one goes from 1 to 5. So it has an amplitude of 4. And I would look down here, and the three remaining graphs do have an amplitude of 4, so I'll just roll out 3 again here. So now I'm still between 3 graphs. So I'm going to look at writing this now as a sine function or a cosine function. So I'm going to find the phase shift for a sine function or a cosine function. So if I was going to find the phase shift for sine for graph 1, this would be the phase shift for sine. I'm going to look at where my graph would normally start, which is back here at 0. But it doesn't. It begins right here. So I can see my graph has been shifted by 60 degrees. So it's 60 degrees to the right. So let's have a look and see if we can find anything that fits these characteristics now. So I know it's not going to be here. This is a cos graph with a phase shift of 90. And this is a cos graph with a phase shift of 60. So I know it's not that either. So it has to be this graph. And just to confirm, we'd also like to look at the period of this graph. The period of this graph would go from 90 to 10. So it looks like we've got a period of 120 degrees, or a third of the original, and we see a 3 right here. So graph A matches with number 2. So now let's look at the second graph. So I'm just going to erase out my x's here. For the second graph, we've got a maximum at 5 and a minimum at -3 again. So the midline will be in the same location as last time. Also, if we look at the amplitude runs from 1 to 5 again, so the amplitude is 4. So what we're able to do right away is rule out number 3, because again, amplitude of 5 here. So we know now we're going to have I or IV, or 1 or 4. So it's going to be a cosine curve or a cosine function. So what I want to do now is look at the period and look at the phase shift. The period may be easy to determine because it doesn't look like there's much going on here. So my first maximum is occurring, or even my graph starts here at 0, 0, and it repeats at 360. So the period of this graph is 360 degrees. So I know that there isn't actually a b value, or the b value is 1 for the function. So when I look at I and IV, or 1 and 4, this one has a period that's been affected by a value of 3, whereas this has the value of 1, so it would have the original period. So graph number 1, or sorry, function number 1 is going to match graph number 2. And also, if I were to look at the phase shift of this, normally our graph would start over here at a maximum, but it's been shifted 90 degrees to the right, which in the equation will be the opposite, so -90. So we can see all characteristics fit.